In this problem, we're talking about a power station in a factory. We've got a river, and we're trying to run a power line. It costs more money, $25 a meter to run it in the river. It costs $20 per meter to run it on the land, and we want to figure out what value of x, and x is already on our diagram, is going to minimize that cost. So we just have to find x in here. All right, so let's go ahead and do this. So we want to minimize cost. All right, so that means we need to find a formula for cost. All right, so the cost is running the line diagonally across the river and then across here. All right, so the first thing I notice is this is a right triangle, and I can find this distance by using the Pythagorean theorem. So x squared plus 60 squared, so x squared plus 60 squared, and then take the square root. That's that distance. And then across the river there, it costs $25 per meter. So this is the number of meters. I'm going to multiply that by $25 per meter, and that'll get me cost. So over here, there's the first portion. 25, the square root of x squared plus, and let's go ahead and multiply that out, 3,600 plus this portion. Well, the whole thing is 200. This little bit is x, so this is 200 minus x. That's the number of meters I have. But on land, it's going to cost me, and I multiply by $20 per meter. All right, so I come over here, and I've got 20 times 200 minus x. All right, so I've got my formula, and we're ready to take the derivative to find that critical number. So here we go, dc dx equals, so I've got 25, and see, derivative of the inside is going to end up going on top, 2x. The derivative of the outside is going to be 2 root x squared plus 3,600. There it is. Plus the derivative of this. So I have my constant, and the derivative of the inside is -1. All right, there we go. So now I want to figure out when this thing equals 0. So I've got 0 equals, and I've got basically, actually these twos cancel. Let's go ahead and cancel those. So that takes me back to 25x over the square root of x squared plus 3,600. And let's see, this is -20. I'm going to bring it over here, and it's going to become +20. All right, let's see, let's multiply both sides by the square root. So I get 20, the square root of x squared plus 3,600 equals 25x. Let's see. Well, I've got the square root. I really want to get that out of here because I think that's causing me problems. So I'm going to square both sides. So 20 squared is 400. This thing is going to just become x squared plus 3,600 when I square it. Over here, 25 squared is 625 x squared. All right, and so this doesn't look too bad. So 400 x squared plus, I'm just going to write this as 400 times 3,600 because I think this is going to work out okay for us, equals 625x squared. I see a lot of perfect squares. It's like a math team thing. So I subtract 400x squared, another perfect square. Look at that, 225x squared equals 400 times 3,600. And now I'm going to take the square root of everything. So square root of 400 is 20. Square root of 3,600 is 60. Square root of 225 is 15. Square root of x squared is x, and I'm really close here. So x equals 20 times 60 divided by 15. I happen to know that 15 goes into 60 4 times, and that gets us the answer for x, which is 80.